Hello, STEAM friends. Do I look funny to you today? You look funny to me too. Have you figured out why yet? These bend or refract the light. You try. Can you see me? So silly! Today, we are going to talk about light and shadow. We've already talked about translucent, transparent, and opaque, and the sun. But keep those in mind because they're going to come up too. But our new big words today are reflection, which is like when you look in the mirror and the light bounces off. Refraction, which is how light bends. And I'm going to show you what a solar eclipse looks like. And what a lunar eclipse looks like. Remember we talked about when you're reading words? So this is the word eclipse. And it's the same. Solar eclipse, lunar eclipse. A solar eclipse just means the sun. And a lunar eclipse just means the moon. And we are going to talk about the spectrum of light. This time, our animal is the giant panda. Look at that giant panda. Isn't he so cute? You might have seen a giant panda at our zoo, but they are native to China, which means that's where they normally live. And I don't know if you look very closely, if you can see that he is shaking water off his fur. You see those water droplets? I chose the panda with the water droplets because we are going to talk about how water droplets refract light and make rainbows. I know, we all love rainbows. Rainbows are just the spectrum of light. A rainbow is how we can see the whole spectrum of light. Every color in the rainbow is in white light. And we've talked about our skeletal system when we talked about the bones in our foot. This is your entire skeletal system. Those are all the bones in your body. And today, the part of the skeletal system that we are going to talk about is your skull. That is what the bones in your head look like. Inside, see? There's the nose. Don't pick the nose. There are the teeth. There's the mouth. That's the eye socket where your eyeball is. Remember, we talked about eyeballs. Okay. So, we are going to head over to the whiteboard to talk about light, shadow, reflection, refraction, solar eclipse, lunar eclipse, the spectrum of light. And then we're going to play with reflection, refraction, and shadow. Sound fun? Let's get started. Can you see my shadow? Can you see my hand? Can you see how it changes as it gets closer and further away? Closer and further away. You can do a shadow dance with your shadow and watch your shadow move when you do. You can even take a piece of paper, put it on the wall, and try to trace your shadow. This week, have some fun playing with your shadow. I am going to teach you a magic trick that you can do at home using refraction. Look, see this card? that I put an arrow on, which direction does the arrow face? Watch when I put it behind the glass of water. Can you see it bend? Can you see it facing the other way? Oh my goodness. Same card. Nice straight arrow pointing this way. But when I put it over here, I can make it flip sides and bend and wave and all kinds of fun stuff. Check this out. I have all these fun little papers. And somewhere in here, oh, little turtles. You see the little turtles? They're facing this way. But look at the turtles behind the glass of water. Which way are their heads facing? The other way. Now, if you don't have pretty paper with little turtles or little buses at home, you can just draw any picture you want. And you can make it move in your glass of water. Watch. I'm going to make this guy dance. Oh, he's got two heads. Pretty cool, right? Just a little stick figure. But it can be all kinds of art when the water in the glass refracts it. Refraction just means that light rays bend. So as they're coming in from the air and they pass through the water and they bounce back to your eyeball, they bend in all kinds of cool ways going through water. Okay, friends, first we're going to talk about light. You all know what light is. It's how we see. Do you see my flashlight here? Do you see the rays of light coming out from it? Keep that in mind. We're going to need to remember that when we talk about shadow. But when light travels from one transparent medium, the air, can you see through the air? That's how you know it's transparent. When it travels through one transparent medium and into another, water is transparent. Can you see through it? I can see through it. It's transparent. It slows down and it changes direction. Remember we talked about fast wavelengths and slow wavelengths. When it travels in, it's going at its normal speed. But when it passes through this glass of water, it slows down and it changes direction. Now, the exact same thing happens when it travels through raindrops, because rain is made of what? Water. Huh? Look at that. But something very special can happen when it travels through raindrops or water particles in the air. A very special kind of refraction happens called a rainbow. The rainbow is all the colors in our spectrum of light, our visible spectrum of light that we can see. All these colors, red and orange, yellow, green, and blue. Last there's indigo and a pretty violet too. Red and orange, yellow, green, and blue. Last there's indigo and a pretty violet too. Remember we talked about how all of these colors of light have different wavelengths, different frequencies. So when it is refracted through the water droplets, it makes a rainbow. And the rainbow is our visible spectrum of light. All the colors of light that your eyes can see. Pretty cool, right? different frequencies. So when they're refracted, white light, plain old sunlight, can make rainbows. Oh, so cool. We love rainbows. All right, my friends. Now, let's talk about shadows. Shadows are just the absence of light. It's where the light gets blocked. So, assuming my little object right here is opaque. Opaque means the light doesn't go through it, right? So it's going to cast a shadow. It's going to cast a shadow that's very dark right up behind it because no light can get around there. And then it's going to get lighter the further away you get. And even though the shadow will change shape depending on how you move your object, it's always going to be, you're always going to be able to tell that it's kind of the shape of your object. Like the shadow of my hand is going to look very different than the shadow of this rectangle, right? You guys have seen your shadow in sunlight before. It's not a rectangle, it's the shape of you. It might be a weird stretched out shape of you, but it looks like you. Okay, now something else would happen if this little object right here is shiny like a mirror. It's going to reflect light. We talked earlier about how when you're reading words, you want to see what parts are the same, right? So both reflection and refraction start with R-E. Reflection is the light that bounces off, and refraction is how light is bent. So a reflection, just like your reflection in a mirror, is the light that bounces back to your eyes. So when you look in the mirror, the light of the image of you is reflected into your eyes. Pretty cool, right? So reflection is just the light that bounces off the object. Reflection is the light that bounces off. Refraction is how the light is bent. Let's explore that further on a piece of paper with a flashlight. If you have a flashlight at your house, you can play too. Otherwise, you can watch and just play along later. Oh, I almost forgot. I can't forget the most cool shadows in our entire solar system. I want to talk about a lunar eclipse and a solar eclipse. Remember, look for the parts that are the same. Eclipse is the same word. Lunar means moon. Solar means sun. See? S, like sun. Solar eclipse, lunar eclipse. A lunar eclipse, remember when we talked about how the earth revolves around the sun and the moon revolves around the earth? Okay, so there's very special times where, because of where they are in their orbit, remember, the orbit is just the path they take to revolve around the sun or around the earth. They line up just right so that in a lunar eclipse, the moon falls in the earth's shadow. So the sunlight comes down, but the earth blocks it. And we can't see the moon. Because the moon, unlike the sun, doesn't make its own light. It reflects the sun's light back to us. So if it's in a shadow, it can't reflect light back to us, can it? There's no light. It's blocked. It's in a shadow. That is a lunar eclipse when the moon is in the Earth's shadow. A solar eclipse is when the Earth is in the moon's shadow. So the sunlight comes down and it hits the moon, but the earth goes dark because it is in the shadow. And even in what should be broad daylight, the middle of the day, it can be dark because we're standing in the shadow of the moon. Pretty cool, right? Okay, now we'll explore that a little more on paper. Who turned out the lights? Okay, the reason that I have the lights turned off and only this flashlight, which if you can see, put tape over so that you can only see a little slit of light come out. I'm not sure how well you can see that on the camera, but you don't have to do that. I just did it so it would be really clear when I make this little shiny object cast a reflection. Can you see where it casts a reflection on the paper? I can see it really clearly on my paper, and when I move the object, the reflection moves. Can you see how when I move the object, the reflection moves? Okay, that is reflection. Whichever way I turn the object, it reflects light in that direction. Looks like, even though I thought it would be better on black paper, it's actually even more obvious on white paper. Look at that. The reflection off the object moves as I move the object. See the reflection move? You can find all kinds of things in your house that can reflect the light from your flashlight. Okay. Now, let's talk about shadows. Now, my friends know that my favorite paper is graph paper, and you cannot even see the little squares on this paper, but it has all these little squares on it. And the reason I love graph paper is because it's like math and art in one. So you can see the light coming out of my flashlight, and you can see how the light changes depending on where I move the flashlight. Now, let's try to make a shadow. Can you see how the object blocks the light? Can you see how the shape of the shadow changes depending on where I move the light? Let's see if I can get a really nice shadow, because I wanted to work with you guys on tracing a shadow. This little rectangle is going to be great for that, because the lines off of it are going to be nice and straight. So let's see, maybe if I prop it up on my phone. That helps me get it straight on. All right, now I'm going to trace the shadow. See how the light goes around the object, but it can't go through it because the object is opaque. I would like you to take a flashlight or go out in the sunshine, cast a shadow, and try to trace a shadow. You can do your shadow, you can do the shadow of an object. See how I moved the object and the shadow moves? See if you can make the shadow bigger or smaller. See if you can change the direction of the shadow. See how now it's coming out like this. Look at that. It stays basically the shape of the object. So if I do my hand has a very different shape shadow. See my finger? My finger's not a rectangle, is it? No, it has a very different shadow. And depending on where I move the light, the shadow gets different. So this week's homework is for you to do your own shadow drawing. Hello, kangaroos. Do I look different to you? Does it look like the camera went off and I changed my clothes and then put totally different clothes on for this? That's just because I am recording it on a different day to give you guys an ending just for you. I edited the last video to take out some things I did for just the explorers. So this is our wrap up just for kangaroos. We talked about light and shadow, and we talked about reflection and refraction, the solar eclipse, the lunar eclipse, the spectrum of light. We talked about, my friend, the giant panda. The giant panda lives in Asia and likes to climb trees and eats mostly bamboo. We revisited opaque and transparent, and as the part of the skeletal system that we are talking about, skeletal system we're talking about today is your skull. This is your skull. That's inside your head. Knock on it. It's hard. See, there is the eye socket and the nose and the mouth. And this part is where your brain is, in your skull. And the song I thought we would go out on, since we talked about sunlight and solar eclipse, is "Oh, Mr. Sun, Sun, Mr. Golden Sun, please shine down on me. Oh, Mr. Sun, Sun, Mr. Golden Sun, hiding behind a tree. These little children are asking you to please come out so we can play with you. Oh, Mr. Sun, Sun, Mr. Golden Sun, please shine down on me." I miss you, kangaroos, and I will see you next time.